This screencast covers pages 423 to 429 of Tsokos Chapter 7.1. We'll be discussing 4 more ways of generating electricity. Those 4 ways are solar, hydroelectric, wind, and wave power. Solar power. This picture shows a person installing photovoltaic panels or PV panels on the roof of someone's house. Photovoltaic panels convert sunlight directly into electricity without any moving parts. They're solid-state devices. In this picture we see solar heating panels. Solar heating panels use sunlight to heat water, and water circulates through pipes, and this can be used to provide hot water or heating for a house. The energy we receive from the sun is partly controlled by the power put out by the sun, and partly controlled by the distance we are from the sun, if you remember the equation for calculating intensity in watts per square meter. The power received by the Earth at the top of the atmosphere is about 1400 watts per square meter, but some of that energy is reflected from the top of the atmosphere, so by the time we actually get to the surface, we're looking at more like 1000 watts per square meter, which is a good number to memorize. Perhaps you can see from this graphic that we're only going to get the full amount of power if we're close to the equator, because at that location the sunlight comes in perpendicular to the Earth's surface. If we're up here at a higher latitude, you can see that the same amount of energy is spread out over a larger surface area, so the amount of energy per square meter will be less. A term you may run across is the daily insolation. That's INSOLATION. That's the amount of sunlight received per square meter per day, measured in megajoules per square meter per day. So to summarize the advantages and disadvantages of solar power, one big advantage is the sunlight is free. It's unlimited, we can't run out of it, and it doesn't produce carbon emissions, so it's clean. The disadvantages, a downside to solar power, is obviously, I hope, it only works during the daylight. It's affected pretty severely by cloudy weather. A cloudy day might not appear to be that much dimmer to us than a sunny day, but that's mostly because our eyes and brains adjust to the light level. During cloudy weather, solar panels don't produce very much electricity. Their output's relatively low per area, therefore they require large areas, and the initial costs for putting up photovoltaic panels is pretty high. Another way of generating electricity is by using hydroelectric power. And hydroelectric power basically takes gravitational potential energy that water has and allows it to go to a lower height and converts that into kinetic energy, and which converts that into electricity. There's a few ways to produce hydroelectric power. One is to store water in a lake and let it fall to a lower elevation and capture the energy as it falls. That's by far the most common technique. Another method is tidal water storage, and as the tide rises and falls, you take advantage of the fact that as the water is going back down, you can extract energy from it. And the third method is a pump storage. And basically the way pump storage works is in the daytime, when you want to produce a lot of electricity, you allow water to fall from one lake down to another lake, and you extract the energy from it. And then at night, when the energy is cheap, you use electricity to pump the water back up into the top reservoir, so it's available for the next day. So this is a technique that's used for taking care of the fact that peak electric demand often occurs in the daytime. So here's a block diagram of the energy transformations that take place during hydroelectric power production. You start with gravitational potential energy of water, and you allow that water to fall, to lose height, and therefore convert some of the gravitational potential energy into kinetic energy. That kinetic energy, that moving water, is used to spin turbine blades. Those turbine blades are attached to shafts which turn a generator, which produce electrical energy. Here's a diagram of that process. We start with water that has gravitational potential energy, and we allow that water to fall down through a pipe called a penstock, and that spins a turbine right here, and that spinning turbine rotates a shaft, which rotates a generator, which produces electricity. Let's take a look at the relative advantages and disadvantages of hydroelectric power. One advantage is the water is free, although extracting the energy is not. Another advantage is it's not going to run out. It's a renewable energy source. It doesn't produce carbon emissions, so it's clean. The disadvantage is you can't do hydroelectric power just anywhere. It's very dependent upon geographic location. You need water, you need rain, you need a river, and you need to be able to dam up the river to form a lake. As a result of that process, it requires drastic changes to the environment. Okay, so taking a wild river and turning it into a lake has all sorts of effects on the ecosystem. And the initial costs are high because building dams is very, very expensive. Okay, our next source of energy is wind power. Here's a very broad sketch of what happens if you want to generate electricity using the wind. You start with solar energy. The solar energy causes winds because of differences in temperature, cause air masses to move from one place to another. The wind has kinetic energy, and that kinetic energy is used to turn a turbine blade, a wind generator. That turbine blade is attached to a shaft which turns a generator, which gives us electricity. Here's what's happening in a bit more detail. Okay, so we start with the wind, and the wind is causing a turbine blade to turn. And as that turbine blade turns, that rotates a shaft, which through some reduction gears causes a generator to spin. And those spinning wires in a magnetic field by Faraday's law of electromagnetic induction give us electricity. Let's take a look at how to calculate the theoretical amount of electrical power we could get out of this wind turbine. As a turbine blade rotates, it sweeps out an area which is circular, and the area of the circle swept out is one of the factors which determines how much power we're going to get. We'll see that in the next slide. So if we want to calculate the theoretical amount of power that we can get from a wind turbine, the formula is 1/2 times the area, that's that cross-sectional area of the circular turbine that we just looked at, times rho. Rho is the density of air measured in kilograms per cubic meter, times v, which is the velocity, the wind speed in meters per second, and notice the velocity is cubed, so it's 1/2 a rho v cubed, and that will give you the theoretical power that a wind generator will give you. If you actually do the calculation and compare it with a real wind generator, you'll find that the power produced by a real wind generator is going to be less than this amount because there are losses due to friction and some other factors. So you really should multiply this by some kind of an efficiency factor that will be less than 1 to calculate the real amount of power. Let's take a look at the relative advantages and disadvantages of wind power. An advantage is the wind is free. It's inexhaustible. It's a renewable energy source. It does not produce carbon, so it's clean. And it works really well for remote island locations where you can't run power lines long distances and so on. The disadvantage is you only can make electricity when the wind is blowing, and the wind has to be blowing pretty hard for most of these generators. So even a moderate breeze is not going to generate much electricity. So it's not very dependable. You need to have some backup power. The output is relatively low, and again, that's calculated by the equation we just looked at. Wind generators are aesthetically unpleasant. They make a lot of noise, and they tend to be. People think they're pretty ugly. They kind of disturb the natural landscape. They're not good in cities because buildings will block the flow of air. So we need to do these things out in the open, and the maintenance costs are high because they have a lot of mechanical parts. Okay, the last method of electricity production we're going to talk about today is wave power. As you might suspect, wave power is a method for extracting the kinetic energy in ocean waves and producing electricity. There are a number of different mechanical methods for extracting electrical power from ocean waves, but the only method you're responsible for knowing about is what's called an oscillating water column. Basically, in an OWC or an oscillating water column type generator, you have waves that have kinetic energy that come in, and they're forced to go into a column, a pipe. And as the water rises in that pipe, it spins a turbine and produces electricity. As the water falls again through the pipe, it spins the turbine again and makes electricity. So as the waves go in and out of this column, they produce electricity in both directions. If we want to calculate the power per unit length of a wave that we can generate, this is power in watts divided by the length of the wavefront in meters. So it's going to be watts per meter. And to calculate that, it's 1/2 times the amplitude of the wave squared times the density of water times 9.81 times the speed of the waves in meters per second. So power per unit length is 1/2 times the amplitude squared times the density of water times g times the speed of the waves in meters per second. Now, one thing that's a little confusing about this equation is the capital A in the wave equation is the amplitude of the wave, but the previous equation we had when we were talking about wind turbines, the capital A in that equation is the area in square meters swept out by the turbine. Okay, so these A's are not the same, and that's really, really important to keep those straight. Okay, let's take a quick look at the pros and cons of wave power. The advantages are waves are free, they have a reasonable energy density, they're renewable, we won't run out of waves, and they don't produce carbon, so they're clean. The disadvantages is obviously they only work in places that have waves, and they need pretty large waves to work effectively. Irregular waves, waves that are not nicely periodic, make it difficult to generate electricity, so choppy waves don't work very well. And it's difficult mechanically to harness that low frequency wave motion, so the wave generators tend to have a little trouble with efficiency. Maintenance and installation is expensive. As you can imagine, they're working in a very hostile environment. Salt water is very corrosive, and they need to be offshore, so you're going to need a boat if you're going to service them and so on. Okay, getting the electricity to land is difficult because you've got power lines that have to run under the sea, and the devices need to be able to withstand the huge waves from severe storms. All right, that's it for this week. See you next time. Okay, here's a little reward for those of you who hung in there for the full 12 minutes of this screencast. If you are among the first 10 people to send me a message, direct message in Edmodo, before Saturday, July 12th, you'll receive 2 participation points. How's that? See you later.